Good morning, ladies and gentlemen. Welcome to the video on the chain rule. The sound hopefully will work this time. The chain rule is used to differentiate composite functions, and it is the rule that we'll be using most often throughout the rest of this year. However, composite functions are sometimes difficult to recognize. So, they take the form of one function inside another. That may seem odd, so let me practice building functions and showing you what I mean. And then we'll work on deconstructing them, and then we'll actually differentiate. So, here, if we have g of f of x, what that means is that this f of x function is going into the g of x function. So the result would be 2x takes 7 to the power of 4. One goes inside the other. To write on the screen properly, I'm going to lay it flat so you guys can enjoy looking at the ceiling. Now, here, same again. This function goes inside the g function. You can see the g's x gets replaced with f of x, so the entire thing goes in. So this just becomes sine of x cubed take 3x plus 4. Now, often in calculus, always, we use u to signify the inner function. That's because, and that's about all the reason I'm giving, because I actually don't know why we use u. So it would be quite common to see g of u where u is an inner function. And in that case, that would be 1 over, and then we replace the x with whatever u was, sine x. Alright? Now, let's practice breaking down functions to an inner function and an outer function. And the key here is brackets, or where brackets are implied. So in the first case here, the inner function, this u, is this one in here. X squared take 4. The outer function we could write as sine u. And you can see that sine u, if u is x squared take 4, will result in this function. Now here, brackets are implied. Under the square root, brackets are implied, same with on top of fractions or underneath fractions. The inner function is 2x cubed take x plus 3. The outer function is root of u. So when one goes in the other, we get this result. Same here. The inner function is inside. So cos squared x take 3x. Then this is u squared. Inner is 6x squared take x plus 2. Outer is log u. Alright, so now I've had a little bit of practice of going the inside and the outside function. I'll introduce the chain rule. The actual calculus notation is tricky, but how to use it, I think, is fairly simple. So, here we go. Alright, so if you have something in the form y equals g of u, so an inner and outer function, then dy dx is equal to the derivative of the outer multiplied by the derivative of the inner. You may also see it expressed in any of these ways. Here is, I think, a far better explanation. So if we have a function 5 bracket x cubed plus 7 to the power of 3, the inner function is this something. The derivative is us deriving, imagine that's u, and then we had 5u cubed. If we derive that, the 3 comes down, making the 15 something gets squared. So that's 15 something squared, then multiplied by the derivative of the inner function. That derivative there is this one here, the derivative of the inner function. So the derivative of the inner function is 3x squared plus 7, it was plus 7, now it's plus 0, and then we combine to get the final result. This saves you expanding and simplifying and makes it nice and quick. Alright, so there's a couple of steps to using the chain rule effectively. First is identify an inner function. The inner function here is what's inside the brackets, u. u is x squared take 5x plus 2. I would then find the derivative of u. 2x take 5. Alright, f dash x, therefore, is us finding the derivative of what's effectively u to the 99. Then multiplying that by the derivative of what the inner function is with respect to x. So first of all, we're doing this. This gets derived to 99 u to the power of 98 multiplied by the derivative of the inner. So du dx. It's confusing because du dx can also be used as u prime, and often we just use that because it's easier to write. So then we make the replacement. F of x equals 99. Then in place of u, we have x squared take 5x plus 2 to the 98 multiplied by 2x take 5. So we do the derivative of the outer multiplied by the derivative of the inner. Alright, I encourage you to identify these first and do that even if they're quite an easy problem like this one. Alright, so let's look at slightly more difficult ones. Here, really, let u be 3x squared plus 4. U prime is then 6x. Pretty easy. So then consider f of x equal to the square root of u. If you want to be really fancy, you can write let u equal 3x squared plus 4. You just make it very clear what you're doing. Alright, so square root of u, which is the same as u to the power of a half. So to differentiate this, we would do a half u to the minus a half multiplied by u prime. That inner derivative comes out, and this bit here is the chain rule. Alright, f dash x then is a half bracket, whatever the u was, 3x squared plus 4, to the power of a half, minus a half rather, multiplied by the derivative, 6x. Alright, then it's a matter of tidying this up. That will get you the vast majority of the marks, it just needs a tidy. 6x times a half is going to give us 3x, not 36, 3x, over this negative a half drops the whole thing down and would normally be expressed as a square root. And that's as far as you can go. So, going through the steps. First, find what u is. Second, differentiate it. Third, differentiate the inner multiplied by the outer, make the substitution, tidy up. They're the steps you should go through. If you feel like running the steps down, go for it. Alright, another practice. Here, I'm going to let u equal 2 take x to the power of 4. Alright, so what does this function look like after, u prime then is minus 4x to the power of 3. So what does this function look like after I've made that replacement of u? Well, f of x really looks like 3 over the cube root of u. I'll write that slightly easier form to differentiate. That's 3u to the minus a third. Right? Then, to differentiate, we differentiate this first bit. So we drop the minus a third out the front. Minus a third times 3 is minus 1. U to the minus 4 on 3 multiplied by whatever the derivative of u is. So as soon as we differentiate the outer function, it throws out this inner derivative. Then f prime x equals, now we make the substitution back, minus 1 bracket 2 take x to the power of 4 minus 4 on 3 multiplied by negative 4x cubed. That's come from there. All right. Now, most of the time in the exam, you'll be asked with don't bother to simplify your answers. So often in paper one, in fact, every paper one, the first 3 questions will involve the chain rule to some extent, and there is an acceptable place to leave it. Really, we could make that look a little neater. Looking a little neater would look like this. The negatives combine to make it positive. That negative power will drop it down the bottom. And, that's slightly better, but both are fine. All right. What I'd like you to do is check your understanding. I want you to try and solve this. If you end up there, you're doing well. Try to solve this. If you end up there, you're doing well. So please bring these notes and examples in your reference book to class. And then very simply in class, you'll have the reference book open and we practice. Sound good? All right, I will see you on Tuesday.